Hello and welcome to another Orange Coast College mathematics video. In this video, we're going to be solving compound inequalities that involve the word or. So like last time, we did a video on compound inequalities with and. You need to be able to solve inequalities like these, linear inequalities. And you need to understand this time the union of two sets, because the solution set to this compound inequality, we simply find the solution set to the first inequality, we find the solution set to the second inequality, and then the solution set for the whole compound inequality is any real number that satisfies this or this. So what that means is it's the union of the two solution sets. So we're looking for, again, find the solution set for the first, solution set for the second, and then the solution to the whole thing will be the union of both of those. Okay? So I'm going to assume that you're comfortable solving inequalities that look like these linear inequalities, and that you're comfortable finding the union of two sets. Let's begin with the following example. So as I said before, we start by solving each one separately. So we just do what we need to do here. So I'm going to add 1 to both sides of this inequality, and I'm going to subtract x from both sides. That will leave us with negative 3x on the left side is greater than 6. And then I divide both sides by negative 3 to get x is now less than negative 2. Remember, when you divide or multiply both sides by a negative number, change the order, the direction of the inequality. And then we have to do the same thing on the right inequality. So add 7 to both sides. That gives us 4x is greater than 28. Divide both sides by 4. And we get x is greater than or equal to 7. So these x is less than negative 2 or x is greater than 7. So that's our solution set. Okay, now if we write these in intervals, this is negative infinity to negative 2. This is 7 to infinity with the bracket on 7. Now these two solution sets don't overlap. That's okay, since we're finding the union, it's everything in one or in the other. So the way we write that is just negative infinity to negative 2. Then we use the union symbol, which kind of looks like a U, but it's like that. And then the solution set for the other one. So there you go. Example 2. All right, we first start by solving this inequality. We have to simplify both sides. So we distribute the 5. We get 5x plus 15 plus 4 is greater than negative 1. So that becomes 5x plus 19 is greater than negative 1. We subtract 19 from both sides. We get 5x is greater than negative 20. And we divide both sides by 5. Arriving at x is greater than negative 4. And then for the other one, again, we just have to simplify. So we get negative 7 is greater than 3 minus 9x once we distribute, plus 8. So this gives us negative 7 is greater than 11 minus 9x. We're going to subtract 11 from both sides. We arrive at negative 18 is greater than negative 9x. We divide both sides by negative 9. And again, we have to change the direction of the inequality. We get 2 is less than x. Or you can rewrite it as x is greater than 2. So x is greater than or equal to negative 4, or x is greater than 2. But this solution set is entirely contained with this one, because like x is greater than negative 4 would include all the numbers where x is greater than 2. So the union is just from negative 4 to infinity. Okay. If you're having trouble with these set theory, the intersections for the previous video, for instance, or these unions, just try drawing them on the number line, graphing them on the number line, and then figure out the union or intersection from there. Example 3. First, we start by solving the inequality on the left. This one's relatively straightforward. Subtract 1 from both sides. We arrive at 4x is less than 20. Divide by 4 on both sides. And we get x is less than or equal to 5. Now on the left, or the right inequality, I'm sorry, we have to start by simplifying both sides. So we distribute that 3. So we get 2 plus 3, and then 3 minus 3 times negative 2 is negative 6x is less than 17 minus 3x. So we simplify the left-hand side. We get 5 minus 6x is greater than 17 minus 3x. So I'm going to subtract 5 from both sides. And I'm going to add 3x to both sides. Okay, so I arrive at negative 3x is less than 12, and I divide through by negative 3, and we change the direction of the inequality, so we end up with x is greater than negative 4. So x is less than or equal to 5, or it is greater than negative 4. So if I draw the number line real quick here, here's negative 4, and here's 5. So less than equal to 5 would go up to here, and greater than negative 4 would go to here. So if we look at anything in one set or the other, that's every real number, right, would satisfy one of those two inequalities. So that means our solution set is just negative infinity to infinity. Here's our final example, and the only thing complicated about these is we have some fractions in them, but we start by simply clearing the fractions. So for the left inequality here, we have a 4 in our denominator, so we're just going to multiply both sides of this inequality by 4. And on the left-hand side, the fraction is clear, so we get 2 minus x, right? Because 4 over 4 is just 1. 2 minus x is less than negative 4. I'm going to subtract 2 from both sides, and I get negative x is less than negative 6. I divide both sides by negative 1. That's going to change the direction of the inequality. We get x is greater than 6. Now for the second one, the second inequality, I need to multiply both sides of the equation by 3. So don't forget, when you multiply the left-hand side by 3, you have to distribute it to both terms. Okay, so we're going to get 3 minus 2x, because again, 3 times 1 is 3, and then 3 times 2x over 3, the 3 will cancel out with the 3 in the denominator, leaving with just 2x. On the right-hand side, 13 over 3 times 3, the 3 in the numerator and denominator cancel, gives us just 13. So now we subtract 3 from both sides. We have negative 2x is greater than 10. Okay, and then we divide both sides by negative 2. And we arrive at x. We change the direction of the inequality, so we're dividing by a negative number on both sides, and we get x is less than negative 5. Now x is greater than 6, or x is less than or equal to negative 5. Now this solution set right here, right, this would be negative infinity up to negative 5, and right here this would be 6 to infinity. These two guys don't overlap, but our solution set is anything in one or the other. So the way we write that is just negative infinity to negative 5. And then we write the union symbol, union 6 to infinity. And there's your solution. And that's all for solving compound inequalities that use or. Like the compound inequalities that use and in the previous video, there's a lot going on here. You need to be able to accurately solve these linear inequalities, because you're going to have 2 of them per problem to solve. Find the solution sets, usually in terms of interval notation, and then find the intersection. So there's a lot to practice there. So again, I recommend going back and practicing solving your inequalities first and foremost. And also, if you need the help, go back to basic set theory and learn about those unions. Okay. Until next time, have fun.